Welcome to your personalized deep dive into TiDB source code.
Yeah,
We know jumping into a large code base can be intimidating,
right.
so we're here to guide you through it.
Uh-huh.
We're going to be looking at 5 articles today
Okay.
that focus on exploring and understanding TiDB's source code.
Yeah.
Consider us your expert navigators,
Yeah.
pointing out the most interesting landmarks
Yeah.
and helping you avoid getting lost in the vastness of it all.
Think of it like having a map
Yeah.
that highlights the must-see spots.
Yeah.
So you can get the most out of your exploration.
Exactly. So before we start digging into the code itself,
Okay.
why is TiDB's source code such a good place to start?
There are a few reasons.
Okay.
First, it's written in Golang,
Okay.
which is known for its clear and concise syntax.
Mm-hmm.
This makes it easy to follow,
Yeah.
even if you haven't worked with Golang extensively.
Okay.
Plus,
Yeah.
Golang has built-in support for concurrency, which is really important for a distributed database like TiDB.
So even if I'm not a Golang expert, I
Yeah.
can still understand what's going on.
Absolutely.
That's reassuring.
Another reason is that TiDB is the user-facing component of the database.
Okay.
This means that understanding its code
Yeah.
gives you direct insight
Mm-hmm.
into how user requests are handled,
Yeah.
optimized,
Mm-hmm.
and executed.
Yeah.
That's where the magic happens.
I like the sound of that.
Right.
And the best part is
Yeah.
I can actually run TiDB myself.
Right.
So it's not just theoretical.
Yeah.
I can test
Yeah.
and validate what I'm learning.
That's right. That's also.
And the articles we're looking at today
Good.
provide step-by-step instructions on how to set up your environment,
Yeah.
get the source code,
Okay.
and even which IDEs,
Yeah.
like Golang or IDEA,
Okay.
work best.
Don't worry too much about the technical setup right now.
Yeah.
You can always refer back to the articles for those details.
For now, let's focus on the big picture.
That's good.
So where do we actually start digging into this massive code base?
The articles suggest 2 great entry points.
Okay.
The main function
Okay.
and the dispatch function.
Okay, let's start with the main function.
Okay.
What's so special about it?
The main function is essentially the heart of the TiDB server.
Okay.
It's where the server's lifecycle begins,
Mm-hmm.
from startup to shutdown.
Right.
It's like watching the server come to life,
Yeah.
step by step.
Cool.
You can see how settings are loaded,
Mm-hmm.
how the server connects to storage,
Right.
and even how background processes are started.
It's like seeing behind the curtain, watching the wizard work their magic.
Right.
And I can actually debug this main function,
Yeah.
step through the code as the server boots up.
Exactly.
That's really cool.
With an IDE like IDEA,
Okay.
you can step through each line of code
Mm-hmm.
and see exactly what's happening. You can
Yeah.
even experiment with different settings and observe how they affect the startup process.
Wow, that's powerful.
Right.
Okay, so the main function gives us a high-level overview of how TiDB works.
Yeah.
What about the dispatch function?
Okay.
What's so intriguing about that?
This is where things get even more interesting.
Okay.
The dispatch function is where TiDB receives all the incoming requests, including your SQL queries,
Okay.
and figures out what to do with them.
Yeah.
It's like the central command center
Yeah.
that orchestrates the entire operation.
So if I want to understand how TiDB actually processes my SQL queries,
Yeah.
the dispatch function is the place to be.
Precisely.
Okay.
By studying the dispatch function,
Yeah.
you can see how TiDB handles different types of commands,
Mm-hmm.
how it routes those requests
Okay.
to the appropriate components,
Yeah.
and even how it calculates performance metrics,
Okay.
like queries per second, QPS,
Yeah.
and commands per second, CPS.
Speaking of performance, I remember reading in one of the articles about a nuance in how TiDB calculates QPS and CPS.
Right.
Can you elaborate on that?
Absolutely.
Okay.
The dispatch function
Mm-hmm.
highlights a subtle difference between QPS and CPS.
Oh, okay.
You see, for simple queries,
Yeah.
these 2 metrics are usually the same.
Okay.
However,
Yeah.
when you have a more complex request
Okay.
with multiple SQL statements grouped together,
Yeah.
the dispatch function treats it as a single request.
Okay.
But from the user's perspective,
Yeah.
it might feel like multiple queries.
Yeah.
This can impact
Right.
how you interpret performance metrics.
Ah, that makes sense.
Right.
So the dispatch function can help us understand
Yeah.
those subtle details
Mhm.
about how performance is measured in a distributed database.
Exactly.
That's helpful.
And if we dig a little deeper
Yeah.
and look at what functions call the dispatch function,
Okay.
we can learn even more.
Okay.
We can see how TiDB handles client disconnections,
Yeah.
responds to errors during transactions,
Mm.
and even how it manages things like the bin log.
Wow. So just by exploring these 2 entry points,
Yeah.
the main function and the dispatch function,
Uh-huh.
we're already getting a pretty good understanding of TiDB's core operations.
Indeed.
It's amazing how much we can learn just from these two starting points.
But there's still so much more to discover.
Okay, so we've explored these entry points.
It's okay.
But let's say I want to get a better handle on how TiDB understands the SQL I throw at it.
Okay.
How do I figure out which SQL syntax it supports?
That's a great question.
Yeah.
The article suggests two main ways to go about this.
Okay.
The first is to look directly at the parser.fle file.
Okay.
It's like the blueprint for TiDB's SQL grammar,
Yeah.
defining the rules for how different statements are parsed and understood.
So this is where we can see if TiDB will understand the SQL I'm writing.
Exactly.
Great.
And there's a handy tool called the Goyak support plugin
Okay.
that makes navigating this file a lot easier.
Yeah, that'd be helpful.
The second way
Yeah.
is to actually trace the syntax through the TiDB codebase itself.
Oh, so it's like following the journey
Yeah.
of a SQL query from being typed in to being executed.
You got it.
That sounds fun.
And to illustrate these methods,
Yeah.
the articles look at a couple of interesting examples.
Okay.
One is the show engine statement.
Okay, what's special about that one?
Well,
Yeah.
if you trace how TiDB handles show engines,
Okay.
you discover
Yeah.
it actually uses an internal SQL query
Okay.
to get the data from a system table.
Mm-hmm.
It shows that even seemingly simple statements
Yeah.
can have some intricate internal mechanisms
Yeah.
going on behind the scenes.
That's fascinating.
Right.
It's like realizing there's a whole lot more going on under the hood
Mm-hmm.
than you initially thought.
Another interesting example
Yeah.
is the create temporary table syntax.
Okay.
This example shows how you can figure out
Yeah.
just how much support there is for certain features. You'll see that while the basic syntax might be there,
Yeah.
the full implementation may not be complete yet.
So it's like getting a sneak peek.
Yeah,
What features are still in development?
right.
That could be really helpful.
Definitely.
Yeah.
By understanding these techniques,
Mm-hmm.
you can gain a deep understanding
Yeah.
of what TiDB can do with your SQL
Okay.
and even uncover some hidden gems
Yeah.
in its implementation.
That's incredibly valuable.
Indeed.
So
Yes.
we've talked about entry points
Mhm.
and understanding the SQL syntax that TiDB supports.
Right.
What about configurations?
Okay.
How do I make sense of TiDB's default setting
Yeah.
and how it's all organized?
The key to understanding that is
Yeah.
a variable called defaultconf.
Okay.
This variable holds all the default settings for TiDB,
Mm.
like a master configuration file.
So if I want to see what TiDB will do out of the box,
Yeah,
I should check out this default conf.
exactly.
Okay, cool.
You can see how each setting is defined
Mm-hmm.
and even how it maps to different configuration file formats like TOMML and JSON.
Okay.
You'll also notice that TiDB's configurations
Yeah.
are structured hierarchically.
Okay, what does that mean?
Well,
Yeah.
for example,
Yeah.
all the settings related to logging
Okay.
are grouped together,
Yeah.
allowing for granular control over how logging works.
Mm-hmm.
It's like organizing a complex system
Yeah.
into a logical tree structure.
That makes sense.
Right.
And I'm guessing by looking at the default conf variable,
Yeah,
I could not only understand the default settings,
right.
but also try out different configurations
Yeah,
by changing the values there.
you got it.
Awesome.
It's like having a sandbox
Yeah.
where you can experiment with different settings
Mhm.
and see how they affect TiDB's behavior.
That's a great way to learn.
Right.
So we've looked at configurations broadly,
Okay.
but what about those fine-grained controls?
Yeah?
The things we can tweak to fine-tune TiDB's performance.
You're talking about system variables.
Right.
Okay.
System variables are like the knobs and dials
Yeah,
that let me adjust TiDB's behavior,
right.
but how do I even begin to understand all of them?
Well, your journey starts with the tidbors.go file.
Okay.
This file is like a dictionary of all the system variables.
Mm.
It's where each variable is named
Okay.
and defined.
So tidbors.go is where I go to find out what variables even exist.
Right. And then from there,
Yeah.
you want to look at the default sysvars structure.
Okay.
This structure is like the instruction manual for each variable.
Mm-hmm.
It tells you the scope of the variable,
Okay.
its default value,
Mm-hmm.
and even some information about how it compares to
Yeah.
similar variables in MySQL.
So default sysvars is like the control panel
Yes.
where I see what each knob does
Mm-hmm.
and what it's currently set to.
And to understand
Yeah.
how these different scopes work in practice, the
Mhm.
articles give us a few examples
Okay.
for read-only variables,
Okay.
which have a scope of scope known.
Okay.
They use performance schema max mutex classes as an example.
Okay.
You can read its value, but you can't change it.
It's like a setting that's hardwired into the system.
Exactly.
Okay.
For global variables,
Okay.
which affect the entire TiDB instance
Yeah.
and have a scope of scope global.
Okay.
They use gated mode as an example.
Okay.
This example shows that if you change a global variable,
Yeah.
it stays changed even after you restart the server.
So it's like a setting that's stored persistently,
Precisely.
not just a memory.
And for session variables,
Okay.
which are specific to a user's connection and have a scope of scope session.
Okay.
They use RANC2 as an example.
Okay.
This shows that changes you make to a session variable
Yeah.
only affect the current session
Okay.
and don't impact other users or connections.
So it's like each user gets their own set of controls
That's right.
that don't interfere with anyone else.
Yeah. While these scopes give us a good starting point,
Yeah.
there's more to the story.
Okay.
The actual way these variables work
Yeah.
can be a bit more complex
Okay.
than these initial categories suggest.
Oh.
Yeah.
What do you mean?
Well, for example,
Yeah.
some session variables can also act like global variables
Okay.
under certain conditions.
Right.
And there are other variables that are purely global
Mm-hmm.
and used by background processes,
Yeah.
like those that handle DDL and statistics.
So the lines can blur a little.
Yeah.
What else makes these variables complex?
Well, there's this fascinating mechanism
Okay.
called global variable functions.
Okay.
To make things run faster,
Yeah.
TD caches the values of global variables.
Okay.
This means it doesn't have to constantly go back to the TiKV storage,
Okay.
which is where the actual values are stored.
That sounds like a smart optimization.
It is,
Okay.
but there's a trade-off.
Right.
Because of this caching,
Yeah.
there could be a small delay
Mm-hmm.
before changes to global variables
Okay.
become visible to new connections.
So it's like a delay in the system catching up to the change.
Yes.
Okay.
It's a classic example
Yeah.
of what's called eventual consistency in distributed systems.
Yeah.
Sometimes you prioritize speed and efficiency,
Right.
and you accept
Yeah.
a little bit of lag in perfect consistency
Yeah.
as a result.
That makes a lot of sense.
Right.
It's like waiting for a web page to update after you make a change.
Exactly.
It doesn't happen instantly.
Yeah. So even a seemingly straightforward concept like
Yeah.
system variables
Mm-hmm.
can have some underlying complexity
Yeah.
when you're working with a distributed database like TiDB.
This is all incredibly helpful.
Yeah.
But I'm realizing we spent quite a bit of time talking about how the system works internally.
Mm-hmm.
What about monitoring its behavior from the outside?
Okay.
How can I tell if TDB is actually performing well?
That's where metrics come into play.
Okay.
Metrics are essential for keeping an eye on TiDB's health
Yeah.
and performance.
Okay, so what kinds of metrics does TiDB use?
TiDB uses two main types of metrics.
Okay.
Histograms
Okay.
and counters.
Okay.
Histograms capture distributions of values like execution times,
Mm-hmm.
so you can see how long different operations are taking.
Huh.
Counters, on the other hand,
Yeah.
simply track how many times certain events have occurred.
So histograms give me a sense of how the system is performing over time.
Yeah,
And counters tell me how often specific things are happening.
you got it.
Okay.
And the articles show us
Yeah.
how to find the code for these metrics
Yeah.
and how it's all organized into namespaces and subsystems.
Mm-hmm.
They even walk us through a specific example,
Yeah.
the TPS metric,
Okay.
which stands for transactions per second.
Okay, what's so special about the TPS metric?
The TPS metric
Yeah.
is a great example
Yeah.
of a histogram metric.
Okay.
You can see how it's defined. How it uses labels like type and TXN mode
Okay.
to categorize different kinds of transactions
Mm-hmm.
and how it's actually calculated
Okay.
using functions like rate sum
Mm-hmm.
and...
So it's like a real-world example
Exactly.
of how metrics are defined and used in TDB.
And the cool thing is,
Yeah.
you can trace that metric definition
Mm-hmm.
back to the actual code
Yeah.
where it's implemented.
Okay.
This connection
Yeah.
between the abstract definition and the concrete code
Yeah.
is really helpful for understanding how it all works.
That's a great point.
Right.
It's one thing to know a metric exists,
Yeah.
but it's another to see how it's actually calculated and used in the code.
And there's one interesting detail I wanted to point out.
Okay.
To improve performance,
Yeah.
the TiDB developers created many pre-instantiated global variables,
Okay.
specifically for metrics.
Oh, okay.
This just highlights the emphasis on performance optimization
Right.
that's baked into TiDB's design.
That's impressive.
Right.
It shows they're thinking about performance at every level.
Absolutely.
Okay, cool.
So
Yeah.
we've looked at these high-level metrics
Right.
that give us a sense of how the system is doing.
Yeah.
But what if we want to understand specific functions,
Okay.
the core pieces of code that make TiDB tick?
Yeah, that's a great point.
Right.
We've talked a lot about concepts and components, but I'm ready to dive into some actual code.
Then let's do it.
Okay, cool.
The articles highlight a few functions
Okay.
that are particularly insightful.
Okay.
One of them
Yeah.
is the execute function.
Okay, what does execute do?
The execute function
Okay.
is like a guided tour
Yeah.
of how TiDB processes SQL queries.
Okay.
It handles the entire flow
Yeah.
from parsing the SQL, using the parse SQL function, to compiling it,
Okay.
using the optimize function, and finally executing it,
Right.
using the execute statement function.
So if I want to see the big picture of how a SQL query gets turned into action, execute is the function to study.
You got it.
Okay.
And then from there,
Yeah.
the articles take us into another key function,
Okay.
runs TNMT.
Okay. What's so important about runs TNMT?
Runs TNMT is
Yeah.
like the workhorse of SQL execution in TiDB.
Okay.
Almost every SQL statement you write
Mm-hmm.
goes through this function,
Okay.
except for a few very specific cases.
Okay.
It's responsible for actually executing the compiled SQL
Right.
and handling all the nitty-gritty details
Mm-hmm.
of things like transaction management and error handling.
So it's where the rubber meets the road,
Exactly.
where the SQL actually gets turned into changes in the database.
And the articles break down
Yeah.
the key parts of this function,
Okay.
explaining what each part does and how it contributes
Right.
to making TiDB robust and reliable.
That's fascinating.
Right.
It's like peeking under the hood and
Yeah.
seeing the engine that drives the entire database.
Precise.
So before we move on to explore other areas, do you have any thoughts or questions about these key functions?
Yeah.
Not really.
You know, we've talked about
Yeah.
how TiDB handles SQL queries, but what about logs?
Okay.
Logs are crucial for understanding
Right.
what's happening inside a system,
Uh-huh.
especially when things go wrong.
Yeah.
How do we go about making sense of TiDB's logs?
That's a great point.
Yeah.
The articles actually provide a really helpful guide
Yeah.
to navigating TiDB logs.
Cool.
They start by explaining the initial startup logs,
Okay.
highlighting crucial information like the welcome message,
Yeah.
the get hash,
Okay.
and the loaded configuration settings.
It's like reading the system's boot up sequence,
Basically.
seeing all the components coming online.
And then they move on to routine startup logs, focusing on the creation of
Yeah.
the initial system tables.
Okay.
These logs give you insight.
Into how TiDB prepares itself
Right.
for user interactions.
It's like watching the system lay the foundation
Right.
for all its future operations.
And then we delve into DDL logs,
Okay.
which are essential for understanding schema changes.
DDL logs.
Yeah.
What's so special about those?
DDL logs are very detailed.
Okay.
They capture every step of a DDL operation,
Okay.
from adding DDL jobs
Okay.
to starting,
Yeah.
running, finishing, and marking them as complete.
Yeah.
And each operation has a unique ID, making it easy to follow its progress through the logs.
So it's like having a detailed audit trail
Precisely.
for all the changes to the database structure.
And lastly, the articles cover logs related to connection management.
Okay.
You can see how TiDB logs the start of the MySQL protocol listener,
Okay.
how it records new connections and connections being closed,
Okay.
and how each connection gets a unique ID for tracking.
So it's like having a record of all the conversations the server is having with its clients.
Decoding these different log types can give you a deep understanding
Yeah.
of what's happening inside TiDB
Okay.
and help you troubleshoot issues effectively.
That's incredibly valuable.
Right.
It's like having a Rosetta Stone
Yeah.
for deciphering TiDB's behavior.
Speaking of deciphering behavior,
Yeah.
let's move on to a more challenging topic.
Okay.
Understanding TiDB's stack logs.
Stack logs.
Yeah.
Those can be pretty intimidating.
Right.
Especially if you're not that familiar with Golang.
You're absolutely right.
Yeah.
TiDB, being written in Golang,
Yeah.
produces stack traces that can be long and hard to read at first glance.
So how do we make sense of these stack logs?
Well, the articles provide some helpful tips. For example,
Yeah.
you can use commands in a text editor like Vim
Okay.
to format the logs into a more readable Golang-style stack.
Yeah. Okay.
This can help you quickly pinpoint the module where an error occurred.
So it's like cleaning up a messy crime scene
Exact.
to find the crucial clues.
And then they introduce us to a powerful tool
Okay.
called Panic Parse.
Okay, what's special about Panic Parse?
Panic Parse
Yeah.
is designed specifically for analyzing Golang stack traces,
Okay.
making them much easier to understand.
Yeah.
It can show you both active and inactive Golang teams,
Okay.
the relationships between them,
Yeah.
highlight important keywords,
Okay.
and it even works on Windows.
So it's like having a detective partner
Precise.
who specializes in Golang crime scenes.
With Panic Parse,
Yeah.
you can unravel the mysteries hidden within TiDB's stack logs
Okay.
and gain valuable insights
Yeah.
into what caused errors and panics.
That's incredibly helpful.
Right.
It takes a lot of the fear out of facing those daunting stack traces.
Absolutely.
Okay.
Now, armed with the knowledge
Yeah.
of decoding logs and stack traces,
Right.
let's shift gears and talk about debugging. Common errors in TiDB.
Okay.
One of the most frustrating
Yeah.
you might encounter
Yeah.
is the lost connection to MySQL Server during query error.
Yes. That one can be a real head scratcher.
Right.
It's always unsettling
Yeah.
when you suddenly lose your connection,
Right.
especially in the middle of something important.
Absolutely.
Yeah.
And the articles we're looking at
Yeah.
do a great job
Mm-hmm.
of breaking down
Yeah.
the three main reasons
Okay.
this error occurs.
Okay.
Timeouts,
Okay.
those pesky recoverable bugs,
Mm-hmm.
and the more serious panics
Yeah.
that TiDB can't recover from.
So it's a process of elimination
Yes.
to figure out the culprit.
We can think of it like a detective story.
I love a good mystery.
Right.
So who are our main suspects in this case?
Well, the usual suspects are
Uh,
timeouts,
Okay.
those pesky recoverable bugs,
Mm-hmm.
and the more serious panics that
Oh,
can
yeah.
bring the whole system down.
Okay, let's start with timeouts. What exactly causes a timeout in this context?
So
Yeah.
TiDB has this variable called wait timeout,
Okay.
which determines how long a connection
Yeah.
can remain idle
Mm-hmm.
before the server automatically closes it.
Okay.
Now, here's where it gets interesting.
Okay.
Unlike MySQL,
Yeah.
which has a default timeout of 8 hours,
Yeah.
TiDB's default is actually 0.
0.
Yes.
So does that mean
Right.
TiDB connections just stay open forever?
Yes, that's right.
Wow.
By default.
Okay.
TiDB is very patient.
Yeah.
It's like it's saying, take all the time you need, I'll be here waiting.
Yeah.
But of course,
Yeah.
you can configure a specific timeout
Mm-hmm.
if you want more control.
That makes sense.
Right.
So if I do need to set a timeout,
Okay.
where do I look in the code to understand how that works?
The articles point to a function
Okay.
called getSessionVarsWaitTimeout.
Okay.
This function is where that wait timeout variable comes into play.
Mm-hmm.
And it shows you
Yeah.
how the timeout mechanism is actually implemented.
So it's not just a setting in a configuration file.
Right.
There's actual code that enforces this timeout.
That's right.
Okay.
And it's important to remember
Yeah.
that timeouts
Yeah.
can occur in other parts of the system too.
Oh. Mm-hmm. What do you mean? Yeah.
Think of it like a chain.
Okay.
You might have a proxy server
Yeah.
sitting between your application
Right.
and the TiDB server.
Okay.
Or in a distributed setup like TiDB,
Mm-hmm.
you have different components
Yeah.
communicating with each other.
Okay.
A timeout could happen at any point along that chain.
So the connection could break down in multiple places.
Yes.
That can make troubleshooting a bit more challenging.
It can.
Yeah.
But thankfully, TiDB has some tools
Okay.
to help us track down these issues.
Like what?
Well,
Yeah.
there's a monitoring metric
Okay.
called disconnection counter.
Okay.
This metric can tell us
Yeah.
whether a disconnection was normal, like a client closing the connection gracefully,
Yeah.
or abnormal, like a timeout or some kind of unexpected error.
Ah. So it's not just a simple on-off signal.
Right.
It actually gives us some context
Exactly.
about why the connection was lost.
It's like having a detective's magnifying glass.
I like it
Right.
to examine the scene of the crime.
Okay, we've looked at timeouts.
Yeah.
What about those recoverable bugs you mentioned?
Yeah.
I'm curious what those look like in the code. So
Yeah.
recoverable bugs are essentially errors
Yeah.
that might cause a part of the TiDB system to stumble,
Okay.
but not fall completely.
Right.
TiDB is designed
Yeah.
to handle these errors gracefully
Mm-hmm.
and try to keep running.
It's like TiDB has some built-in resilience.
Yes, exactly.
You can take a punch and keep going.
But even though TiDB can recover from these bugs,
Yeah.
it might still terminate the current connection
Mm-hmm.
as a safety measure.
Oh.
It's like saying, okay, something went wrong here,
Mhm.
but I'm going to isolate this connection just to be safe.
That's a smart approach.
Right.
Better to be safe than sorry. Right?
So how do you know
Right.
if one of these recoverable bugs has happened?
Well, you'll see a specific error message
Yep.
in the log that says connection running loop panic.
Uh-huh.
And the log will also include the last SQL query that was executed before the panic occurred.
Right.
This information can help you pinpoint
Yes.
what might have triggered the bug.
It's like TiDB's giving us a little clue.
Yeah, I like it, to help us solve the mystery.
Now let's move on to our final and most serious suspect,
Okay.
the panics
Okay.
that TiDB can't recover from.
These sound a bit scary.
Right.
What kind of situations would cause these unrecoverable panics?
These can be triggered by
Yeah.
really critical bugs
Okay.
that TiDB just doesn't know how to handle,
Mm-hmm.
or by system-level issues,
Okay.
like completely running out of memory.
Right.
In these situations,
Yeah.
the entire TiDB server might go down.
So it's a full system crash.
Yeah.
That sounds pretty serious.
It is.
Yeah.
And unfortunately, in these cases,
Yeah.
TiDB might not even have time to write anything to the log before it
Yeah.
crashes.
Mm.
So we might not have
Right.
as many clues to work with.
That makes things more difficult to debug.
Right.
But is there anything that can be done
Yeah.
to help recover from these kinds of crashes?
Well, most TiDB deployments
Okay.
use tools like Ansible or TIUP to manage the system.
Right.
These tools are usually configured
Yeah.
to automatically restart the TDD server if it crashes.
So it's like having a safety net that
Exactly.
catches the system and tries to bring it back online.
And you can usually tell
Yeah.
that a restart has happened
Okay.
by looking at the uptime
Yeah.
in your monitoring system,
Okay.
or by finding a new welcome message in the logs.
Yeah. So even though we might lose some information in the crash,
Yeah.
we can at least see that the system has tried to recover.
That's right.
Okay.
Now, if you want to get to the bottom
Yeah.
of what caused the crash,
Yeah.
you can still try to examine the wreckage,
Okay.
so to speak.
Right.
There's a file called tidbridgeter.log, which usually contains the raw output from the Golang panic
Mm-hmm.
that brought the system down.
It's like going through the debris to find the black box recorder.
Yes.
I like it.
And remember, our friend Panic Parse
Yeah.
can help us analyze those panic logs
Right.
and understand what happened.
And if you suspect
Yeah.
that the crash was caused by memory exhaustion,
Right.
you can also look for resource-intensive queries in the logs.
Right.
These queries are usually tagged with expensive query.
So it's a multifaceted approach.
Mm-hmm.
We need to analyze the logs,
Right.
look at system metrics,
Yeah.
and understand the code to effectively debug these serious crashes.
You've got it.
Now, before we move on to another area,
Yeah.
I'm curious.
Yeah.
What are your thoughts
Yeah.
on all these error handling mechanisms we've discussed?
Well, it's clear that
Yeah.
TiDB has a lot of built-in safeguards
Mm.
to handle different types of errors.
Right.
It's impressive how the system can recover from certain bugs
Yeah.
and even restart itself
Right.
if things go really wrong.
It definitely gives me more confidence
Yeah.
in using TiDB
Yeah,
in a production environment.
I agree.
It's one of the things
Yeah.
that makes TiDB
Yeah.
such a robust and reliable database.
Speaking of reliability,
Yeah.
one of the concepts that I find really fascinating
Okay.
in distributed systems is distributed transactions.
Right.
How does TiDB ensure that
Yeah.
transactions that span multiple nodes
Mhm.
are executed correctly and consistently?
That's a great question.
Yeah.
Distributed transactions are definitely one of the more challenging aspects.
Yeah,
They
I
don't
bet
move
of
back.
building a distributed database.
But TiDB handles them gracefully
Okay.
using a protocol
Yeah.
called two-phase commit,
Okay.
or 2PC for short.
Okay. I've heard of 2PC,
Yeah.
but I'm not entirely sure how it works.
Okay.
Can you break it down for me?
Sure.
Okay.
Okay. In a nutshell,
Yeah.
2PC involves the transaction coordinator,
Okay.
which is usually the TiDB server,
Okay.
communicating with all the participating TKV nodes to
Yeah.
make sure everyone is on the same page
Yeah.
and ready to commit the transaction.
So it's like a group vote
Yes.
where everyone has to agree before moving forward.
A very good analogy.
Okay.
In the first phase,
Yeah.
the coordinator sends a prepare message
Mm.
to each node.
Okay.
It's basically asking, are you ready to commit this transaction?
And what happens if a node isn't ready?
If any node responds negatively,
Yeah.
or doesn't respond at all, the coordinator will abort the entire transaction
Okay.
and send a rollback message to everyone.
Right.
It's an all or nothing approach.
Yeah.
This ensures
Yeah.
that the database remains consistent.
It's like a safety mechanism that prevents
Exactly.
finished transactions from messing things up.
Now,
Okay.
if all the nodes respond positively
Yeah.
to the prepare message,
Mm-hmm.
the coordinator moves on to the second phase
Okay.
and sends a commit message
Yeah.
to each node.
Okay.
At this point,
Yeah.
each node applies the transaction locally to its own data
Mm-hmm.
and acknowledges the commit.
So the first phase is like a confirmation check,
You got it.
and the second phase is the actual execution.
And by studying the code,
Yeah.
you can see
Yeah.
how TiDB implements this 2PC protocol.
Right.
It uses mechanisms
Yeah.
like timeouts, retries, and logging
Okay.
to make sure
Yeah.
that distributed transactions are
Yeah.
handled reliably,
Yeah.
even in the face
Yeah.
of potential problems.
It's like watching a well-choreographed dance,
I like that analogy.
where every step is carefully planned and synchronized.
Now, one of the challenges
Yeah.
with distributed transactions
Yeah.
is handling failures.
Mm-hmm.
What happens if a node crashes in the middle of a transaction?
That sounds like it could cause a lot of problems.
It could.
Yeah.
What does TiDB do in that scenario? Well,
Yeah.
TiDB is designed to handle these kinds of failures gracefully.
Okay.
If a node crashes,
Yeah.
the other nodes in the cluster will detect it
Mm-hmm.
and elect a new leader
Okay.
for the affected region.
Mm-hmm.
This new leader will then catch up
Yeah.
on any missing data,
Okay.
and the transaction can continue as if nothing happened.
So it's like having a backup dancer
Yes, that's a great way to think about it.
who can seamlessly step in
Yeah.
if someone gets injured.
TiDB's ability to handle failures transparently
Yeah.
is one of its key strengths.
Yeah.
It allows you to build highly available applications
Yeah.
without having to worry too much
Right.
about the complexities of distributed systems.
That's really impressive.
Right.
It gives me a lot of confidence
Yeah.
in using TiDB for mission-critical application.
Okay, great.
So we've covered a lot of ground
Yeah.
with distributed transactions.
What else
Yeah.
can we learn from the source code
Yeah.
about how TiDB handles data?
Well, one area
Yeah.
that's particularly interesting to me
Yeah.
is TiDB's data storage layer.
Okay.
Remember how we talked about TiDB being the key value storage engine
Yeah.
that underpins TiDB?
Exactly.
Yes, TiDB is like the foundation of the whole system. It's where the data actually lives.
Exactly.
Right.
And TiDB is designed from the ground up
Okay.
to be distributed,
Mm-hmm.
fault-tolerant,
Okay.
and highly scalable.
Okay.
It uses a sophisticated system of data sharding
Mm-hmm.
and replication to ensure that your data is always safe and accessible,
Right.
even if some hardware fails.
So it's like having multiple backup copies of your data
Precisely.
spread across different locations.
Now, one of the key concepts
Yeah.
to understand in TiDB
Okay.
is the notion of regions.
Okay.
A region is essentially a chunk of data,
Okay.
a contiguous range of keys and their corresponding values
Yeah.
that's stored on a single TiDB node.
So it's like dividing a giant library into smaller sections,
Yes.
each with its own catalog.
It's a very apt analogy.
I like it.
And as your data grows,
Yeah.
TiDB automatically splits
Okay.
these regions into smaller chunks
Mm-hmm.
and distributes them
Okay.
across the cluster.
Right.
This ensures that no single node gets overloaded and that data access remains fast and efficient.
It's like a self-organizing library
Exactly.
that expands and rearranges itself as more books are added.
Now, when you're reading the source code,
Yeah.
you'll notice that TiDB uses a consensus algorithm called RAFT
Okay.
to ensure that all data modifications
Yeah.
are replicated consistently
Right.
across the cluster.
What's a consensus algorithm?
A consensus algorithm
Okay.
ensures that all the nodes
Yeah.
in a distributed system
Okay.
agree on the same state.
Okay.
Even if some nodes fail
Yeah.
or there are network problems,
Right.
in this case,
Yeah.
RAFT is used to make sure
Okay.
that all copies of your data
Right.
are kept in sync.
So it's like having a team of librarians
Precisely.
who constantly compare notes
Yeah.
to make sure they have the same information in their catalogs.
RAFT is a very powerful algorithm
Yeah?
that guarantees data consistency,
Yeah.
even in challenging situations.
That's reassuring to know.
Right.
It's like having a safety net
Yeah.
that protects your data from unexpected events.
Now, to understand how data is actually stored
Mm-hmm.
and retrieved in TiDB,
Yeah.
let's look at the concept of key value pairs.
Okay.
In TiDB,
Yeah.
all data is stored as key value pairs,
Okay.
where the key is a unique identifier,
Right.
and the value is the actual data you want to store.
So it's like a giant dictionary
Exactly.
where each word has a definition.
And TiDB provides a set of APIs
Uh-huh.
for accessing these key value pairs.
Okay.
You can use operations like get to retrieve a value based on its key, put
Yeah.
to store a new key value pair,
Okay.
or delete to remove a key value pair.
So it's like having a basic set of tools
That's right.
for interacting with this giant dictionary.
Now, one really interesting aspect
Yeah.
of TiDB's data storage model
Okay.
is that it supports transactions.
Okay.
A transaction is a series of operations
Yeah.
that are treated
Okay.
as a single unit of work.
What do you mean by a unit of work?
It means that either all the operations
Yeah.
in a transaction succeed
Sure.
or they all fail.
Okay.
There's no in-between state. This guarantees
Yeah.
that your data remains consistent
Mm-hmm.
even if something goes wrong
Right.
in the middle of a complex operation.
So it's like having an undo button
Yes, that's a good way to think about
for
it.
a whole sequence of actions.
Now, TiDB uses a technique
Yeah.
called optimistic concurrency control,
Okay.
or OCC,
Okay.
for managing these transactions.
So-
OCC allows multiple transactions to happen concurrently,
Okay.
but it checks for conflicts
Yeah.
before committing a transaction.
Okay.
If a conflict is detected,
Mm-hmm.
the transaction is rolled back,
Right.
and the client has to try again.
So it's like having a referee
Exactly.
to make sure that everyone is playing by the rules
Yeah.
and that no one is accidentally overwriting someone else's work.
Now, when you're reading the source code,
Yeah.
you'll see
Ah.
how TiDB implements OCC
Okay.
using techniques
Mm-hmm.
like multi-version concurrency control,
Okay.
or MVCC. MVCC allows TiDB
Mm-hmm.
to store multiple versions of the same data,
Okay.
which enables it to provide
Yeah.
what's called snapshot isolation
Yeah.
for transactions.
Snapshot isolation.
Yes.
That sounds intriguing. What does it mean?
Snapshot isolation means that each transaction
Mm-hmm.
sees a consistent view of the
Oh.
database
Okay.
as it existed
Yeah.
at the time the transaction started.
Mm-hmm.
This prevents transactions from seeing partial results
Yeah.
of other concurrent transactions,
Yeah.
which could lead to inconsistencies.
So it's like
Yeah.
each transaction is working with its own private copy
That's a great way to visualize it.
of the database
Right.
frozen in time.
Now, before we move on,
Okay.
do you have any questions or reflections
Mhm.
on TiDB's data storage mechanisms?
I'm really starting to grasp
Yeah,
the complexity and sophistication of TiDB's storage layer.
right.
It's clear
Yeah.
that a lot of thought and engineering effort has gone into making TiDB distributed, fault-tolerant,
Yeah.
and highly scalable.
It's really impressive.
I agree.
It's one of the things that
Yeah.
makes TiDB such a powerful and reliable database
Yeah.
for handling massive amounts of data.
Speaking of handling data,
Yeah.
I'm curious about
Yeah.
how TiDB manages large data sets.
Okay.
Does it have any special mechanisms for optimizing queries
Yeah,
that involve lots of data?
that's a great question.
Yeah.
And yes,
Okay.
TiDB has several optimization techniques
Yeah.
for handling large data sets.
Okay.
One of the key concepts
Yeah.
is the idea
Mm-hmm.
of a coprocessor,
Okay.
or COP for short.
Coprocessor.
Yes.
What is that?
A coprocessor is essentially a piece of code
Okay.
that can be executed
Mm-hmm.
directly on the TiDB storage nodes.
Okay.
This allows TiDB
Yeah.
to push down
Okay.
some of the query processing
Mm-hmm.
to the nodes
Okay.
where the data is stored,
Right.
rather than
Yeah.
having to transfer all the data
Mm-hmm.
back to the TiDB server for
Yeah.
processing.
So it's like bringing the computation to the data
Exactly.
instead of bringing the data to the computation.
This can significantly reduce
Right.
the amount of data that
Yeah.
needs to be transferred over the network,
Mm-hmm.
which can lead
Yeah.
to much faster query performance.
That makes a lot of sense.
Yeah.
So how does this coprocessor concept work in practice?
Well,
Yeah.
when TiDB receives a query,
Okay.
it first analyzes it
Mm-hmm.
to see if any parts of the query
Yeah.
can be pushed down
Okay.
to the TTV nodes as coprocessors.
Okay.
If so,
Yeah.
TiDB generates the coprocessor code
Okay.
and sends it
Mm-hmm.
to the relevant nodes.
So it's like TiDB is delegating some of the work to the TiKV nodes.
Precisely.
Okay.
The Tiki nodes then execute the coprocessor code
Mm-hmm.
and return only the necessary results
Okay.
back to the TDB server.
Right.
This way, TDB only has to process
Mm-hmm.
a small subset of the data,
Okay.
which can greatly improve performance.
That's a really clever approach.
Right.
It's like having a team of specialized workers
Exactly.
who can handle specific tasks more efficiently.
And the coprocessor framework in TiDB
Yeah.
is quite flexible.
Okay.
It can handle a wide range of operations,
Okay.
including filtering aggregation sorting
Mm.
and even joining data from multiple tables.
So it's not just for simple queries.
That's right.
It can handle some pretty complex operations as well.
Now, when you're reading the source code, you'll see
Yeah.
how TiDB determines
Okay.
which parts of a query
Mm-hmm.
can be pushed down as coprocessors.
Okay.
It also shows
Yeah.
how the coprocessor code is generated.
Welcome back to our deep dive into TiDB source code.
Yeah.
It's been quite a journey, exploring everything from entry points
Yeah.
and SQL parsing to error handling and those fascinating coprocessors we talked about earlier.
It's amazing how much we've uncovered
Yeah.
just by peeling back the layers of the code
Mm-hmm.
and examining the mechanisms that make TiDB tick.
I know, right? And today I'm really excited to dive into one of the most fundamental aspects of any database.
Okay.
How it actually stores data.
Mm-hmm.
We touched on TiDB,
Yeah.
the key value storage engine in the last part.
Right.
But I'm eager to go deeper
Okay.
and understand how it all works at a more granular level.
Excellent. That's exactly where I wanted to focus today.
Okay.
TiDB is truly the heart of TiDB,
Yeah.
responsible for storing and managing all the data
Mm-hmm.
in a distributed and resilient way.
So TiDB is like the vast library
Precisely.
that holds all the information in our TiDB database.
But it's not just a simple library.
Okay.
TiDB is built from the ground up
Yeah.
to be incredibly robust and adaptable.
Okay.
It uses these clever techniques like data sharding
Mm-hmm.
and replication to make sure your data is safe
Right.
and always accessible,
Yeah.
even if some of the hardware in the system fails.
Okay, I remember we talked about regions in the last part.
Yeah.
Can you remind me what those are
Yeah.
and how they fit into this whole data storage picture?
Of course.
Okay.
A region is like a self-contained unit
Uh?
of data storage within TiDB.
Mm.
Think of it as a chapter
Okay.
in that vast library we were talking about.
Yeah.
Each region holds a
Mhm.
specific range of keys
Okay.
and their corresponding values.
So instead of having one giant book,
Right.
we have many chapters,
Yeah.
each focusing on a specific set of information.
And how does TiDB decide which data goes into which region?
Well, as you add more data to your TiDB database, TiDB automatically splits those regions into smaller chunks
Yeah.
and spreads them across multiple servers in the cluster. This process ensures that no single server becomes overloaded
Right.
and helps keep data access fast and efficient.
It's like the library automatically reorganizes itself.
Yeah, that's cool.
Right.
And adds more shelves as the collection grows.
But how does TiDB keep track of all these regions that are spread across different machines?
That's where things get even more interesting.
Right.
TiDB uses a special mechanism called a placement driver, often shortened to PD,
Right.
to manage all these regions
Yeah.
and where they live in the cluster.
Uh-huh.
Think of the PD as the master librarian, keeping a meticulous catalog of where every book is located.
So the PD is like the central directory that maps keys to specific regions
Yeah,
and tells TiDB where to find the data it needs.
exactly.
And the PD does more than just maintain that directory.
Okay.
It also monitors the health of the servers in the cluster, balances the distribution of regions to avoid hotspots, and even orchestrates the movement of regions
Wow.
if a server fails
Okay.
or needs to be taken offline for maintenance.
Wow, that's a lot of responsibility.
Right.
The PD sounds like the brain of the whole data storage operation.
It truly is.
Yeah.
And if you're exploring the TiDB source code, I highly recommend taking a look at the PD component. That's a fascinating piece of engineering.
I'll definitely add that to my list.
Okay.
So we have all these regions spread out,
Yeah.
managed by this clever PD component. But how does TiDB actually ensure that the data is consistent across all these different copies?
Right.
We talked about Raft earlier, but how does that actually work in practice?
That's a great question.
Yeah.
Raft is the consensus algorithm
Okay.
that ensures all changes to the data are applied consistently
Right.
across all the replicas of a region.
Okay, so what happens if I want to, let's say, update a value in my TiDB database?
Well, that update request
Okay.
will eventually find its way
Yeah.
to the leader of the region
Okay.
where that data lives. Remember, each region has a designated leader replica.
Right. The leader is like the head librarian for that particular chapter on the library.
Now, when the leader receives your update request,
Yeah.
it doesn't just apply the change immediately.
Okay.
Instead, it first sends out a proposal
Okay.
to all the follower replicas for that region. This proposal contains the specific changes
Okay.
that need to be made.
So it's like the leader is saying, hey, everyone, I'm thinking of making these changes.
Yeah.
Are you all okay with that?
That's a great way to put it.
Yeah.
And the followers have to agree to the change before it becomes permanent.
Right.
Only after a majority of replicas have acknowledged the proposal will the leader actually apply the change to its own copy of the data.
It's like a democratic vote where the majority rules.
Yeah.
So only if enough replicas agree does the change actually happen.
Exactly.
Yeah.
And once the leader applies the change, it notifies all the followers.
Okay.
And they update their own copies of the data as well.
Right.
This process ensures that everyone stays in sync.
That's a really clever way to make sure the data is consistent across the entire system.
It's like having a built-in safety mechanism that prevents data from getting out of sync.
Precisely.
Raft is designed to handle all sorts of challenging scenarios.
Yeah.
Like network interruptions, server failures, and even conflicting updates. It's what makes TiDB so robust and reliable.
This is all making a lot more sense now.
Right.
But let's zoom in even further.
Okay.
We've talked about regions, leaders, followers.
Yeah.
But how is the data actually organized within a region?
Right.
What does it look like at the lowest level?
At the lowest level, all the data in TiDB is stored as key value pairs.
Right. We talked about that before. It's like a giant dictionary.
Yeah.
But how are all these key value pairs arranged within a region?
TiDB uses a structure called a log-structured merge tree, or LSM tree for short, to organize these key value pairs.
Okay.
Think of it as a special kind of index that allows TiDB to efficiently store, retrieve, and update data.
Okay, another tree structure. We've encountered a few of those already.
Right.
What's special about this LSM tree?
The LSM tree is designed for performance, especially when it comes to writing data.
Right.
It organizes data in a series of sorted files called SST files, which are immutable, meaning they can't be changed once they're created.
So how does TiDB handle updates if these files can't be changed?
That's a great question. Instead of modifying existing SST files, TiDB appends new key value pairs to a separate structure called the mem table, which is kept in memory. As the mem table fills up, it's flushed to disk as a new SST file.
Ah, so it's like writing to a log file first.
Or C.
And then periodically organizing those entries into more permanent storage.
And to handle reads, TiDB has to search through these SST files, starting with the most recent ones, however, to speed things up. TiDB also maintains a block cache, which stores frequently accessed data blocks in memory.
So it's like having a shortcut to the most popular books in the library.
And over time, TiDB performs a process called compaction, where it merges smaller SST files into larger ones, removing any deleted or outdated key value pairs in the process. This helps to keep the storage footprint efficient and prevents the number of SST files from growing uncontrollably.
That's really clever. It's like tidying up the library and removing any books that are no longer needed.
Yes. And if you're curious to learn more about how all of this works at the code level, I encourage you to look into the storage package within the TiDB source code. You'll find the implementation details of the LSM tree, the mem table, and all those fascinating mechanisms for handling data persistence and retrieval.
This is all incredibly insightful. I'm really starting to appreciate the depth and sophistication of TiDB's storage engine. But let's shift gears a bit and talk about something we haven't touched on yet. How does TiDB handle those situations where you need to make changes to the database schema while the system is running?
That's a great question.
Yeah.
We've talked about how TiDB handles DDL statements.
Right.
But those typically involve some level of locking, which can temporarily pause certain operations.
Okay.
However, TiDB also offers a powerful feature called online schema change, or OSC, which allows you to make schema modifications with minimal impact on running applications.
So OSC is like a way to remodel the library while it's still open to the public.
With OSC, you can perform operations like adding or dropping columns, renaming tables, or even changing data types without having to take the entire database offline.
That sounds incredibly useful.
Right.
How does TiDB manage to pull that off without causing any disruptions?
The magic behind OSC lies in a clever technique called background backfilling. Instead of making the changes directly to the live data, TiDB creates a new temporary structure to accommodate those changes. It then gradually copies the data from the old structure to the new one in the background.
So it's like creating a new set of shelves in the library.
Precisely.
And slowly transferring the books over while people are still browsing and checking out books from the old shelves.
And throughout this process, TiDB ensures that all read and write operations are directed to the appropriate structure. So your applications continue to function normally without any inconsistencies.
That's really impressive. It sounds like a very carefully choreographed operation.
It is. And the implementation of OSC in TiDB is quite complex, involving a lot of coordination between different components. If you're interested in exploring the code behind OSC, I recommend checking out the DDL package in the TiDB source code. You'll find all the fascinating details about how TiDB manages the backfilling process, handles conflicts, and ensures data consistency throughout the schema change.
This has been an amazing journey. We've covered so much ground.
I know.
From understanding how TiDB processes SQL queries to diving deep into the storage engine and exploring features like online schema change. I feel like I have a much better grasp of how this whole system works.
I'm glad to hear that. It's been a pleasure exploring the intricacies of TiDB with you.
Thank you.
And remember, the journey doesn't end here. There's always more to discover within the TiDB source code.
Absolutely. This deep dive has sparked my curiosity even more.
Great.
And I encourage anyone listening to do the same. Don't be afraid to explore the code. Ask questions and share your discoveries. The more we understand about this powerful system, the more we can appreciate its capabilities and contribute to its ongoing evolution.
Well said. Thanks for joining us on this adventure into the world of TiDB source code.
Until next time, happy coding.